what if machines wrote the content that you see on our service? No, this is not going to happen, right? This is not something that Netflix is looking at, but it's an interesting thought, right? What could machines help us see that we cannot presently see? Could they give us novel themes or introduce new subgenres or unexpected plot twists that we've never seen before? So we're not working on this, but the folks over at Botnick are. And I did not realize this whenever I put the slides together, but they're going to be here tonight at Data Science and the Census. So I'm looking forward to meeting them and hearing their thoughts. But they worked with the folks at College Humor to put on a skit that was generated by machines. So I'm going to show you just a little clip of that.
Interior, College Humor sketch. Grant reads a website page about how to get a Jar Jar body. He will pass away underneath the couch exactly 1 year from today. Allie, Katie, Reka, Raphael, and Siobhan are sitting around the table like bad candles on a half-assed cake.
Hey Grant, did you meet anyone at the ocean?
Piece of seaweed touched my mouth and I swallowed it.
That's flirting!
Trap enters with pieces of coconut in his hair.
Let's get this meeting started like yesterday. Woo! Siobhan?
These 4 friends have to steal a car, but just when they're about to use the new phone, a stranger has celiac disease.
Just gonna use a tiny computer now.
A sketch where a shark touches my leg, and I just love it so much.
My pitch is too afraid to walk out of my mouth right now. Not because it's dumb. It would probably read the New York Times.
Okay, this one's called When the Salad Man Flirts with People. It's about how vegetables are getting super friendly.
A sketch where I eat the kind of rice that would be totally great right now. I need vitamin I. Rice.
So as entertaining as that is, and it gets better, it goes on for about 5 minutes, we're just not there yet, right? And I think many people could argue that we'll never be there, that machines are not well suited to creative endeavors. But what we can do is use them to help inform our decisions and to augment our creative processes. And so that's what we're doing. Now, I started working on the engineering side of data science more than a decade ago. The first project I worked on was back in 2007. So we had built this rules engine, and it was pretty simplistic at the time. It was just an A/B split, and we were using it for marketing messages. And we saw phenomenal improvement just by doing that simple testing and iterating on it. So then we decided, well, that worked well. Let's get fancy. Let's see if we could build a predictive model using a logistic regression algorithm. Now, I had no idea what that meant. I'd never heard the term before, but I looked into it, and the more I learned, the more I realized, yeah, that makes a lot of sense. And so we did it, and 14 painful months later, it was in production, and it was a phenomenal success, and it changed the way the company operated forevermore, and it changed my life as well. And so when I look at where we are today, though, it feels to me very much like we're living in the future, right? Like the future is now. I could have never imagined back then that we would have so much data around us, that we would have these algorithms and models that are affecting every aspect of our life. I mean, we walk around with the entirety of our civilization in the palm of our hand, in our pocket. Does anybody else like to look at the smart home thing and play around with that stuff? Like, I love that stuff. I've got the smart lights and speakers and the cameras and thermostat, and I just bought a Wi-Fi enabled smart Instant Pot. So, don't know how that's gonna work, but in theory, when I get into my car, which can drive itself, it's going to notify my smart pot, and it's going to start preparing my meal for me, right? Like it's mind-boggling that we can do these things. But being on this side of it, and this side being the data science side of it, the people that are actually making it happen, we realize, man, this stuff, as pervasive as it is still really, really, really difficult to do. And what's really interesting to me is that the problems that we're looking at today are very similar to the problems that we were dealing with 10 years ago. right? There's some things that have improved. I mean, we have Jupyter notebooks. We have this amazing, on-demand cloud infrastructure. We have distributed processing and unstructured data technologies like Hadoop and Spark. It makes things a lot easier. But a lot of the problems still remain. And here's the thing. We're on the cusp of it. Like, I believe strongly that we have the ability to dramatically affect the quality of life with the work that we do. I mean, I imagine most of the people in the room feel the same way, right? So I really want to see us be able to do that and to be successful in that. And so when I hear about these problems that people have, these things that are really just, they're either easy to solve or they're really hard to solve. It doesn't really matter, but I think the more we can pour our collective knowledge, the better off we'll all be as a society. So what I want to do in this talk is share with you some of the things I've learned over the last decade, specifically on the enablement side. How can we help these processes scale? But first, I'm going to take a quick look at Netflix and give you some background context. The company is living in this intersection between technology and entertainment, and it's thriving. We have 149 million members worldwide as of Q1 2019. And most of that growth now is happening internationally. In fact, international subscribers have surpassed our domestic subscribers. We also account, according to Sandvine, we account for 15% of worldwide traffic, which is mind-boggling. Like, I can't even really fathom that. This is an interesting number, though, so as cool as it is, it's actually something that we look at a lot, we really care about a lot, and we are trying to constantly reduce this number. And when I say reduce, like, we don't want you to stop streaming, we just want to lower the amount of data that it takes for you to stream. And so that includes things like, can we improve our compression algorithms or do better encoding or give you smart downloads? One of the most interesting things I think about the company is how it's constantly evolving and reinventing itself. So it started as a DVD business. Anybody subscribed to DVDs back then? Wow, okay, so a lot of you. So it started in '97, I became a member in '99, and I remember hearing, DVDs and mail, that's never gonna work, right? And it did. And then a few years later, they started with the streaming, the online streaming, and I heard people say, that's never gonna work. And I was a member back then, and I subscribed, and the content choices were somewhat slim. But they've constantly improved and iterated on the product ever since. And so here is what the service looks like today, if you log in. And we've taken that concept of constant iteration and we've really embraced it, right? So we're constantly testing the product, we're throwing out new iterations of it, seeing how it performs, and then if it's doing well, we roll it out. So even though I showed you big changes, the changes are actually happening incrementally. One of the things we've learned is that the best forum for showing you video is to actually show you video. It's gonna describe it better than pictures and words ever would. So.
Hey, Alice.
Hey?
Long time no see.
Who are you?
I'm Eve.
As in Adam and Eve?
So you get a better sense of what the content's about from that video, right? We take that concept, we personalize, and I think everybody here has heard about Netflix and personalization, right? But every single aspect of the product is personalized for you. And when I say for you, I mean every single profile. So not just the 149 million members, but for each profile on there, we personalize every single aspect of the product, from the billboard that you see, the video that is now displayed within that billboard, the rows, the ordering of the rows, the titles, all the way down to the actual images themselves. So if you looked at the site without any images, it would look something like this. And there's one algorithm that's telling you what are the right rows to show you, what are the right titles, and then there's another one that is looking at the right images to display. And even this image selection process has evolved, right? So when we first started, it started with a single image, then we went up to, and that was coming from the studio, and then we said, well, we can do better than that. And we provided a list of options, and we tested them over the general population, and we said, which is the right image for us to actually use? And then we constantly iterate on that again. And we got beyond just broad personalization, and we said, what is the right image to show this person, right? Given their taste profile and like the type of content they enjoy watching. And so you can see here on the left, actually both of these appear on my account depending on which profile you're on. On the left, if you're watching the feel-good films, you're gonna see that one. On the right, if you're watching a lot of anime or action, you're gonna see you know, the one on the right. And even the thumbnails, if you notice this, are personalized. Okay, so we'll come back to that stuff in just a moment, but let's go back to the future and let's talk about how do we scale? How do we do this stuff at a greater scale? Now, first, I've given a lot of talks and I talked to a lot of people, and I realize that one of the challenges with giving talks is that the things that you hear are not always feasible or applicable. And so my goal in giving this talk is really to present you with some ideas on things that you can do in your environment. You can pick and choose the ones that make sense, versus trying to sit there and say, be very prescriptive and say, you should do this. That's not what I'm suggesting. But these are things that help you scale. Also, this is a topic that is a very, very broad topic. I could talk about it all day long and still just scratch the surface. So I tried to pick the pieces that I think are most broadly applicable. But if you have other questions about this, I'm happy to talk to you guys afterwards. All right, so the first component of scalability is systems and tooling. My favorite, this is the stuff I like to build. And here is one of those tools that we built at Netflix. This is called Ava. And so I was just talking about image personalization and how do we do that. Well, when we started, we had 6 images that we were selecting from, and those were all created by an artist. They would go for each title and select 6 of them, and they would test each of them, and then based upon the actual results, that would be what won. But as Danny just mentioned, there's some implicit human bias within that process. And not only that, but it's also really laborious, right? There are, I think, 9 million frames in the typical season of television. And that's a lot of work to sit there and have somebody try to crawl through those. And so instead we built Ava, which does the initial image selection process for us. So it's gonna look through each one of those frames, and it's gonna search for things like image clarity and the amount of noise that it's in the image, and the, you know, how well is the face seen, or is it visible? We also build a lot of infrastructure. So this right here is a look at our notebook infrastructure, but we have infrastructure for machine learning and experimentation and scientific computing. And so each of those are their own things. But if we're looking just specifically at notebooks, which actually spans all 3 of those, on here you'll see we've got users. And when they want to go into a notebook, they start in a UI. And the goal for us is to obfuscate the complexity of that infrastructure from the user. They shouldn't have to know about cloud-based environments. They shouldn't have to know about AWS and S3. They should just really be able to focus on what it is that they do and what it is that they do well. So Interact, if you're not familiar, is a next-gen UI for Jupyter. It's something that my team had been investing in. And when you go to this notebook UI, behind the scenes, we're doing a lot of things for you. We are launching a Titus container. Titus is our open source container management system, but you can think of this like Docker image, right? So we launch this for you. We connect you with a whole bunch of services that exist, like Metacat, which is a federated data metastore, and Genie, or data catalog. And then we've got Genie, which is a federated job execution engine. You don't need to know about those things, right? Like, you can go learn if you really need to, and sometimes data scientists need to go learn more because the amount of data that they're trying to process is too much, so they have specialized needs. But for the most part, you guys don't care about that. You don't want to learn about it, and your teams don't want to learn about it. So instead, we just simply provide all of this as a service. So I could talk about tooling all day long, but tooling is kind of like the given. It's the obvious answer, right? Like, how do we scale? Well, build tools. The challenges with scaling actually go beyond the tooling. And in fact, the tooling's almost the easy part. It's everything else that's really hard. The first thing is deciding what to build. And I find that people just simply look at the human process and they try to automate it, and that doesn't work very well. When you're building these tools, I think one of the first principles you need is to decide, do you want to lean into simplicity or flexibility with the tool? Now, ideally, in a perfect world, we get both, and sometimes you can. But you first need to be thoughtful and intentional about which of those two things are you trying to do. And I think the same thing is true whenever you're purchasing tools too. Which are the two that you're trying to solve? So here's an example of I think, a situation where we leaned into both. So we got simplicity and flexibility. So we're going to take a look at our notebook infrastructure from the user perspective. And I mentioned that we launched that container on your behalf. You don't have to do anything, but if you want to configure it, you can do it right here from that UI. I think notebooks, and I love notebooks. I think they're phenomenal. And I think why they're so phenomenal is that they do both. They lean into simplicity and flexibility, right? But we took it a step further, and we added some custom magics like SQL, so that whenever you're writing a query, you don't need to know about the metastore, you don't need to know where this data is sitting, you just write a query. So this is phenomenal, right? I think it's really amazing what it enables in terms of data science, but I think we can do better. And so we were looking at Interact. Interact is, as I mentioned, that next-gen UI, and it's React-based. And because of that, it allows us to do a lot of really cool things, such as Data Explorer, which is what you're seeing here. Data Explorer is a way to interactively, see what I did there? Interactively explore the data sets that you return. And because we really wanted to focus on simplicity, we wanted to make it easy to get to this. So we worked with the Pandas data team to adopt a new spec so that every time you return a Pandas data frame, we can automatically provide you with 24 visualizations for free out of the box. But this is an area where we leaned into simplicity at the cost of flexibility. You can do some really cool things, but you can't do everything. And that's okay, because you have those options available to you in the form of like Matplotlib and other visualization libraries if you need them. Here's an example where we leaned into flexibility over simplicity. This is Metaflow, which is our machine learning infrastructure. And here we could have built a UI, but that would have been too limiting, right? Instead, we said it's going to be a little bit more complex for you to learn how to use this library, but the benefit is that you can plug it into anywhere else that you're working with, Python code, and a lot of people do that inside of a notebook. Accessibility. When we look at the problems that data scientists face and where they spend their time, we have visualization challenges, which we've helped with, but there's three things that end up taking a lot of time. Data discovery, understanding the data, and being able to read and write data, right? So I have a friend that I was talking to a few weeks back, and he works for a very large company that has recently experienced a data breach. And when I was talking to him, he was perplexed. He could not understand how they had gotten access to the data, because it took him 7 weeks to get access to the data. The worst part is it wasn't even private data, right? There was nothing sensitive that in the database he was trying to get access to. And I think that the real tragedy, aside from the data breach, but from his perspective, is that you were not only not successful at keeping out the hackers, but really what you did, the only thing you were successful at, was creating this impediment to your data scientist. You became a blocker for them. And this happens time and time again, right? Now, I'm not suggesting you don't secure your data. That's absolutely not what I'm saying. But what I am saying is that there is a lot of hoops that people have to jump through, and they're unnecessarily complex. A lot of the time, when people are trying to secure data, they say, we're going to put up this barrier, and you cannot get through unless you have the right credentials or we vetted you. And so then you get to that point where you get into the system and then you have the access that you need and you can do lots of things. We take a very different approach. We say, if you're an employee, you should have access to the data, again, sensitive, private data aside, but you should have access to the data because we're gonna assume that if you're trying to look at the data, you're trying to do it for a business purpose because that is going to be true almost every single time. But we still care and we want to secure our data. So private data is put separately, and that is a separate pre-approval process. And then for everything else, we monitor what it is that you're doing with the data. We use data science, we build models, and we look for those unusual patterns of behavior. And when we see them, we immediately automatically shut off that account, and now you have to go talk to a person. It's a much better, more scalable way to approach those types of problems because you've removed that artificial barrier you've created for your people. Another thing is people get very, very protective around their data, and they don't want to share it or make it accessible. And we take a fundamentally different approach, and we say, again, if you're trying to look at the data and you're an employee, you probably have a valid business reason. And if you don't, you might have curiosity, and guess what? Curiosity is a good thing too. Really great ideas come from curiosity. So we want to enable that and empower users as much as we can. Every single person in the company can access our big data portal, which is the gateway to the entire platform. If you have a question, if you're looking for a data set, you can search here. It will show you the reports. It will show you the tables. It will show you any related workflows. We do not try to delineate by roles or teams or departments. And as a result, we save everybody a lot of headaches. We save ourselves headaches, we save our users headaches, and again, people can get to what they need faster, which is a key part of scaling. This is just a look. If you had clicked on one of those tables, we try to provide as much data as we can to the users, and we go after the things that you're constantly looking at or doing the most, right? And so one of the biggest things we see is, what does this table mean? Who owns it? When was it last refreshed? We have, again, we're using data science to make this easier. So you can see maybe life cycle, which shows active. And so we have this algorithm that's really trying to determine where is this table in its phase of life cycle. Is it a brand new table that I probably shouldn't have a lot of trust in? Is it a table that's broadly used? Does it have data quality on it? So we're looking at those things and we're providing that information to the users to make it easier for them to find the right table. We also, I mentioned we don't delineate by role, right? So we also make it to where everybody can use the platform, regardless of whether you're a data scientist, data engineer. It shouldn't matter what your role is. If you want to create a job, a recurring job, why wouldn't we let you do that? Right? And I keep hearing people, they say, oh, I don't have permissions to do that. I don't understand that, right? Because data scientists are very much data producers. They have workflows, they have tables that they own. So we want to give them the same tools, and actually better tools in many ways, than we do for our data engineers. And one of the things that we did with our notebook infrastructure was make it really easy for them to be able to schedule those jobs on a recurring basis. But here's an area where we had to lean into simplicity, right? Because our data scientists are not data engineers, and we wanted to surface the information for them whenever they're trying to troubleshoot a failure, because they now own this job, right? So when there's a failure, they're on the hook to fix it. So we surface the error messages right here in the portal. We give them nice visualizations. They can restart from here, and then if they want to click into it, they can click into it and see the actual notebook that ran with all the parameters that ran at that time. So that doesn't sound like maybe a big deal, but it really is, because when you create these jobs, you have a lot of parameters such as your date, and when you're trying to reproduce that failure, it's difficult to understand what was it that actually ran at that point in time. And so having that notebook, which is that immutable reference or artifact of that execution, is really powerful, makes it easier for them. So again, we leaned into data scientists being able to create their own workflows, making it as easy as possible. And then here, this is just a look at more of the analytics that we provide to our users. We provide information around what was the amount of data that was read, how long did it take. And the reason why we did this is because they will ask the question now, like, I'm a data producer, I own this thing. Why is it taking so long to run? Well, it's taken a long time to run because you're reading a lot more data than normal. Maybe there was a backfill, right? But giving them those answers makes it easier for them, and it actually reduces the amount of time they spend maintaining the things they've already built, and instead let them focus on creating new value for the company. Here is a look at our experimentation platform. So this is Ablaze, which is used for A/B testing. And again, same premise here. Everybody in the company can view this. All right. So you can see here there is some specialization that we are doing in terms of the infrastructure. I mentioned we have specialized machine learning, scientific computing, notebook, all of these different teams have specialized infrastructure. But when I'm talking about specialization here, I'm actually talking about specialization of people. So think about where you start in the evolution of data science in a company. You start off with your full stack unicorn. You want somebody who can go end to end. They can start with the data, they can write the jobs, they can do the analysis, they can do the modeling, feature engineering, productionalization, maybe they write some reports. It's really powerful, but there's two challenges with this. The first one is that they're hard to find. And secondly, think about what happens when you're going through this process. You might not run or write Spark jobs very often. You can do it, and maybe one time it's really easy for you to do because it's a small data set, but then you run into that problem where you run out of memory, and you don't even know what that error message means. You don't know that you ran out of memory. You don't know what the setting configuration is, and now all of your work has screeched to a halt because you're not a data engineer. You're a generalist. The more we allow our people to specialize, the better they can scale because they built that body of knowledge. Now, I'm not suggesting you get rid of your full stack unicorns. I'm suggesting here that you give them the opportunity to pick an area that they are most passionate about and to go specialize in that. If we take a look at Netflix, we have a lot of people, a lot of different data roles. So this is kind of like a high level view. But I start with what I think of as the people who are your traditional data producers or people that are tasked with building a data product. This is the value that they provide to the company. They produce an asset which is then used by somebody who is responsible for delivering a data insight to the business. This can be in the form of an analysis, it could be a model, and the output of the people focused on the insights is used by the business in terms of making business decisions, informed business decisions, or by building products such as like the image personalization that you saw, right? But it's going to go to one of those two places. So we have people that specialize in each of these specific roles and then some. And we do that per org, right? So we've got all of these people that work on product, but then we also have people that work on content and people that work on studio and finance and marketing and personalization and so on and so forth. And even this is an aggregated view because if you drill down further, you'll find we've got multiple teams underneath each of these. You've got your content team is broken up into, let's say, your originals and your unscripted and your documentaries. And these people specialize in these areas, and that's valuable because of the skills, but it's also valuable because of the domain knowledge. So the more you want to scale, the more you want to specialize. Autonomy. We are on track, well, we spent $12 billion on content last year. We're on track to spend $15 billion on content this year. 15 billion, right? If you think about the general premise here is we've got all of this great financial resources at our disposal that we're investing in content. How do we know how to best spend that money? Well, we use algorithms, right? So we have a predictive model that will look at the potential audience for a given title. And then we look at something called the efficiency, like product efficiency or content efficiency, which is for a given title, what is the optimal amount of money for us to offer for that, to license it? given the amount of people that might watch it, right? So this is actually a really great way of looking at content and attribution here, because it's letting us spend a lot of money on titles that have broad appeal, and a lot less money on titles that might have more of a niche audience, but we're still serving those niche audiences, right? We're still able to fund them. So we do this by looking at characteristics of the film, and if it's something that's already been created elsewhere, it makes it easy for us, because easier, I should say, because we can look at how it performed and what like the sentiment of that is and what the buzz is around it. It's a little bit more challenging when we're trying to figure out how to create content. And this is an area where, a majority of our spending is now going to is around the content creation. So what we do is very similar. We try to break it up into attributes that we can use to proxy what that content might look like. So this could include things like the creator of the show. We can say, okay, well, Matt Groening is very successful, so that's a positive checkbox there. And we can say, well, we know how animated shows perform for adults, and we can look at all of these different attributes of it and estimate what the audience might be. But then what about Stranger Things? Anybody watch Stranger Things? Okay, good number. For those handful of you who did not raise your hand, it's a little bit of a tricky problem here, because we can't rely on genre matching in the same way. We've got 80s nostalgia here at play. We've got some sci-fi, some fantasy, some mystery. So there's a lot of things that go into this. We also had the Duffer Brothers, who at the time were not well known. All of the talent in the show was not well known. So there weren't a lot of things for us to be able to use. But what we do is we give people in the role, in that content purchaser role, autonomy in decision making, because we've hired them because of their special expertise in that space, right? They know better whether something will be a hit or not. And so what we do is we don't use the models to make the decisions for us. We use the models to inform the decisions. And that's not true just inside of those content purchasing spaces. We do this across the board. If you are here at the company, we expect that you're trying to do what it is that we've asked you to do, right? So why would we get in your way? You have autonomy over the tools that you use, over the languages that you use. You have the ability to pick and choose and control your environment so that you can be successful. So if we take a look at this, I don't know if anybody has seen Father of the Year. We could say this is a data quality issue potentially. So let's say that's what happened. So let's say it was a data quality issue. What do we do? What can we do? Well, there's quite a bit of things that we can do. The first thing is we can help give you tools for data quality. We can automatically collect statistics for you whenever you write data. And then you can tell us what are the fields that you care about, right? So maybe we care about row counts and null counts within this data set. We can give you a library that allows you to tell us what your expected ranges of values are for this. I mean, maybe you're saying this is within a normal distribution and it should be within like a 95% confidence interval. We can give you frameworks that make it really, really easy for you to be able to have those quality checks in place before the data is visible to downstream processes. And then, because we always care about flexibility too, you can customize it if you want to, but you don't need to. You just get it for free by using the platform. We can give you tools that are going to show you what the historic performance has been so you can see whenever you get those error messages, what's happening? Why did I get that? Is this a false positive or is this a real problem? What we should not do and do not do is tell you that you need to have data quality on every single thing that you push to production. And I've heard repeatedly that this is the case. Companies will sit there and they try in the name of efficiency and scaling to put these rules in place. You must do this before you can deploy to production. You must have a code review. You must have data quality in place. You must have unit test. Those are all excellent things that I highly recommend most of the time. But what is data science? It's a lot of experimentation, a lot of prototyping, a lot of throwing something out there and having no idea if it's going to work at all. So you want to deploy to production, you want to run it, you want to monitor it for some period of time, and then you want to make a decision. And that's the point at which you should start doing these things, right? So rather than us enforcing that or requiring it, we say, we're going to give you the tools. I mean, I can actually sit there and predict this table needs data quality, and it should have this check on it, and this check, and this check. I can do all those things, and I could even do it automatically for you, but I shouldn't require it. And I shouldn't do it automatically because I don't actually know. You guys know. So when you think about scaling, and this is just one of those things that doesn't make sense. People do it in the name of scalability, but it actually is an impediment to scaling. The paved path is another one of those. So we have this concept of paved path, which says if you are on this road, you're doing everything the normal, typical way, and you're going to get all this goodness from the platform. You're going to get like the automatic data quality notifications, or all of those tools I showed you. The data sets that you create are automatically discoverable. You don't have to do anything. But that doesn't work for everybody. When we're designing infrastructure, I try to go for like this 80% rule, and I look at all of the people we're trying to serve, and I look on one side of the spectrum. We have our content team. And they have lots of very small data sets. And oftentimes, there's no data in the data set at all. Then on the other end of the spectrum, I've got personalization. And they've got just a couple of data sets. But man, are those things large. They've got trillions of rows. The solution I build for one should also work for the other, right? But on one end of the spectrum, I've got people writing Spark SQL. And on the other one, I've got them writing Scala. So instead, I try to go for that 80% and say, is something going to be broadly useful? And then I give people the ability to go off the paved path, do whatever it is that they need to do, and come back onto the paved path, right? So again, that flexibility is key in terms of being able to get people to use what it is that you built and actually be successful in scaling with it. And then the last one is culture. So this one's a little bit controversial. I don't know if you've read the article about Netflix, but and I'm no longer there, but I can tell you in all honesty, I love the culture. It's not right for everybody, but it was right for me. And I think that it's actually the company's culture that enables it to be so successful in working with data and in scaling that. If you are not familiar with the culture, you can go to SlideShare. And I didn't know this at the time, but I guess SlideShare has been around for 9 years, who knew? And the Netflix culture deck is one of the, I think it is the most viewed slide up there by a considerable amount. So people are always asking, what is that Netflix secret sauce? There is no secret, it's actually out there publicly. Like literally, this is how it is inside of the company. So if you're wondering what it's like or how we're able to do it, that has the answers. Now, actually doing it, whole other story, whole other level of complexity. But how we do it and what we do, it's all right here. So they have this premise of freedom and responsibility, and I kind of touched on this a little bit when I was talking about autonomy. But the core concept here is that you have the freedom to do what it is that you need to do and the responsibility to do it. So I've hired you to do this job. You're the expert in it. I'm going to get out of your way. Why would I try to micromanage? Why would I sit there and try to tell you what tools you need to use? You know better than I do. But you have the responsibility to deliver. If you want to go off the paved path and build your own thing, if you want to build your own library, if you want to use Zeppelin instead of Jupyter, you have that right, that ability. But you're also on the hook for managing it. And I find that that works as a very effective checks and balances, right? Because people don't want to sit there and be on the hook for having to manage their own software. They want to be able to not have to worry about any of the infrastructure. They want to worry about the data. But if I don't give them that freedom and responsibility, then I am going to do one of two things. I am going to force them to not do what it is that they need to do. So they're gonna be twiddling their thumbs while they're waiting for permissions or waiting for something to get installed. Or they're gonna go around whatever it is that I did, trying to be able to help, right? Trying to be able to do their job. So don't make people choose, right? Just give them that freedom and that responsibility. This is the company policy for expenses. It's one line. Act in Netflix's best interest. So removing all of these complex policies and boilerplate, it really comes down to the concept of we have employees, we trust those employees, and we want to minimize the amount of extra stuff as much as we can. Another thing about the culture, and this is actually one of my favorite stories, it was a key moment for me. Whenever I first started, I had this really great conversation with one of our data science leaders. And she said, you know, we're actually really, really, really good at predicting behavior for people that are exactly like us. So if you happen to be a 30-something-year-old Caucasian woman that works in tech, I have a pretty good chance of being able to guess how you're gonna respond to something. But looking in the room, I can see that that is not a majority necessarily. So the best thing for us to do is to recognize that up front and to use systems that are gonna eliminate the bias that we have and really be able to test it, right? And so I look at this as the one example. They had more options available, but they did a little game, and they were like, who thinks this is the most popular image, and who thinks this is the most popular image? And I remember being flabbergasted that, I mean, which one do you guys think won? The one on the left? The one on the right? Yeah, that's what I thought. The one on the left outperformed the one on the right significantly, right? Like, why? I still don't understand. But the company recognizes this as a truth, and they built this entire culture around experimentation and testing and being able to prove out your hypothesis. They've also made it okay to experiment in ways that might result in failure. So I mentioned whenever they said we were going to do DVDs, everyone's like, that's not going to work. And then we were going to do streaming. That's not going to work. Well, we wanted to schedule notebooks. That's not going to work. And then they're like, yeah, that could work. Okay, well, it was going so well, we were like, let's run all data engineering jobs through a notebook and schedule in production. That's 150,000 jobs a day. What? Why would you do that? That makes no sense. Well, we did it. It was phenomenally successful, right? For the reasons I mentioned earlier around the visibility and the ability to quickly reproduce and the ability to quickly troubleshoot. Our data engineers have loved it, and it's actually become a gateway for them, or an on-ramp for them to use notebooks. And guess what? This was written by one of our data engineers. They love notebooks because it solves a lot of the challenges that they had in data engineering. But let's say we had done that and it had not worked. It would have been okay as long as we had made a smart bet, or we had taken like an informed risk, and we learn from our mistakes. We take a step back and we say, why didn't that work? Now, I've been working on this data quality solution there, and I can tell you it's the 4th iteration of data quality that we've done. Data quality is a phenomenally difficult problem to solve. But each of the ones that we did before, and I say we, some of them predated me, they were all useful in that we learned things along the way, and the solution we've arrived at today has actually been pretty successful for us as a result. Sometimes the things that you build will not operate in the ways that you expect. And I think the way that you respond to that and the way that the people around you respond to it is also a critical component. I'm going to skip over this, though, because we're almost out of time, and get to this last thought, which is that I think the biggest benefit of working at Netflix is that there is one goal, which is to help the company succeed. That's it. And so I was talking to a data scientist who works at another company, and she wanted some advice because she was working on this product, and she had this idea, and she wanted to test it out, but she was afraid to make a suggestion to the product manager because the product manager had been dismissive of her ideas in the past and wanted her to focus on the modeling and not on the product. Leave that to me. That makes no sense, right? When you take a step back and you say, what is it that we're here to do? They're all working on the same problem, trying to improve. In their case, it was like the landing rate, right? They were trying to improve the same metric. I think when you look at a lot of the problems that we have with scalability and a lot of data science, there's a lot of fighting that goes on, whether it's between a product manager and a data scientist, or whether it's between security and engineering, or whether it's people competing because they've been incentivized to incentivize that I know what it is that you're working on is really important, but I've got a financial incentive. I have to do this and deliver it this quarter to hit my bonus, right? And when you do those things, people stop making the right decisions. And so if you really take a step back and you look at the problems that we face, there's a surprising amount of this stuff going on. So I wanted to call that to your attention in case you guys are not aware. So that is my talk. If you are interested in learning more about any of the things I've talked about, there is the Netflix tech blog, and then there's the research website. I'm also going to be sticking around for questions after this, and I am happy to, at any point during the conference, if you see me and you have a question, please stop me. Thank you.